Hi and welcome! In this video we're going to implement Sierpinski Triangle. I'm using D programming language and Raylib graphics library. The code should be quite similar if you're using another language. Sierpinski Triangle is a self-similar triangle, or triangular shape, divided recursively into smaller triangles. Thus, if we start with a single triangle, on the next iteration we get 3 more triangles. On the third iteration we get 9 more triangles. 3 triangles more inside of each smaller sub-triangle from the previous iteration. And it iterates infinitely many times. Let's start by creating a Sierpinski triangle function. For now, it will just display a triangle. The function will take 3 points as arguments. Then I will draw a triangle using these points. Run the code and you should get your triangle. Alright, now we need to calculate 3 new points of new triangles. So we have our initial points P0, P1 and P2. And what we need to do is to divide each side of our triangle by 2. Now using these midpoints we can draw new triangles P0, A, C. Another one using A, P1 and B. And the last one using C, B and P2. Let's code it. Let's calculate the position of point A. It will be the position of P0 x plus P1 x divided by 2 and P0 y plus P1 y divided by 2. Copy and paste it 2 more times and change P0 to P1 and P1 to P2 for B and P1 to P2 and P2 to P0 for C. Now let's draw triangles using these points. And here's what we get, 3 new triangles. Now we need to iterate each step again and again. We can use recursion for that. So instead of calling drawTriangle function, we can call Sierpinski Triangle. It will divide those 3 triangles into 3 smaller ones, and will continue doing so until the program crashes or freezes up. Therefore, we need to limit the number of iterations, and once we're done, we would like to draw those triangles. That's why the function needs one more parameter called limit, and if limit is less than or equals to 0, we would like to draw the triangle using these points and skip the rest. And down here, when calling a Sierpinski Triangle function again, the 4th argument will be limit -1. I will set the number of iterations to 6. Compile and run to see the results. We can also animate this process. Slow down your frame rate to 5 FPS. Next, let's create a new function called Sierpinski Triangle Animation. It will take the same 3 points of a rectangle as arguments and a reference to the limit variable. Inside the function, we increment the limit by 1, and if limit is greater than 13, we make sure it does not exceed 13. It makes no sense to make the number of iterations even greater because you won't see the difference. And down here, let's call the Sierpinski Triangle function. Compile and run to see the results. Alright, that's it for today.